Hello everyone, welcome to Dakshana e-classroom program, and this is a solution video for exam DT13 for NEET students. And I hope everyone tried their best during your exam, and you must be knowing that the questions which you were not able to solve during your exam are also important for you to understand at least after the exam, because this is not your final exam, or this was not your final exam. You are still preparing for your final exam, so learning from your mistakes, learning from your questions which you were not able to solve your exam is also equally important. And I hope this video will be helpful for you people in understanding, in clearing all those questions, your doubts which you were not able to solve during your exams. Let's continue without any delay, and here we are going to start with question number 1. So here we have question number 1. A vessel contain an ideal monoatomic gas which expand at constant pressure when heat q is given to it, then work done in expansion is. तो यहाँ पे क्वेश्चन नंबर 1 दे रखा है, constant pressure expansion हो रहा है and heat q is supplied. So what we can write, how much heat? It is equal to n cp delta t, and it's monoatomic gas, so cp is equal to what? N. This is 1 plus f by 2 into r into delta t, and this is coming out to be for monoatomic gas, it's 5 r delta t into n divided by 2 is the q. So this is the heat supplied, and it's asking about the work done in this process. So work done in constant pressure is given by P delta V, V2 minus V1, that is equal to NR delta T, and from here we can get the value of NR delta T, that's coming out to be, so W is equal to NR delta T, that is 2Q divided by 5, and this is the work done, matching with option number 3. Next question number 2. Friction coefficient between the two blocks as shown in the figure is mu, and horizontal plane is smooth. If blocks are slightly displaced by x from mean position, then what can be the maximum amplitude of if the upper block does not slip over the relative to the lower block? ठीक है ना. तो यहाँ पे देखो क्या हो रहा है, this situation, this is your system, this is m2, this is m1, and friction coefficient mu, spring constant k, and this is your r, right? तो अभी क्या होगा, जब इनको डिस्प्लेस करते हैं तो दोनों ब्लॉक्स का एक्सेलरेशन, अगर x एक्सपेंशन आता है, then what is the force? kx, and because both blocks are moving together, so acceleration can be written as kx divided by total mass m1 plus m2, right? And this block will have this much acceleration only because of what? Friction force. So if friction force is sufficient enough to provide this acceleration, then it will be like good enough. So here what it's asking, like, what can be the maximum amplitude if the upper block does not slip? So means x will be the maximum amplitude, and this must be equal to what? Mu times m1 into g. Is that clear? It should be mu times m into mu times, because I am writing acceleration. तो यहाँ से solve करके अपने पास आता है amplitude, and that will be equal to x is your amplitude displacement. This is mu times g times m1 plus m2 divided by k. So this will be answer, which is matching with option number 3. Okay, next question number 3. So here, particle is executing SHM along a straight line. Its velocities at different point at distances x1 x2 from the mean position are given by v1 and v2 respectively, then its time period is. तो यहाँ पे अपन को ओमेगा निकालने का है, then time period. So we know the relation between velocities. v1 is equal to omega times root over, let's say amplitude is a square minus x1 square, and v2 is equal to omega times root over a square. A is the amplitude times x2 square, right? Squaring and dividing both of these, then v1 square by v2 square, this is coming out to be omega gets cancelled, a square minus x1 square divided by a square minus x2 square, right? This, and I'm writing 1 minus this, 1 minus this comes out to v2 minus v1 whole square divided by v2 square. This is equal to a gets cancelled, this is coming out to be x1 minus x2 whole square, x1 square minus x2 square divided by a square minus x2 square, and rearranging it, I'm getting it actually a square minus x2 square. This is coming out to be v2 and square times, this is taking it that side, x1 square minus x2 square divided by v2 square minus v1 square, right? This is up to here. Now we know actually v2 is equal to omega times root over this. Root over this is equal to what? This quantity root over this, that is equal to v2 multiplied by x1 square minus x2 square divided by v2 square minus v1 square whole this, and this implies omega is equal to root over v2 square minus v1 square, this whole divided by x1 square minus x2 square. So we get omega, then time period is equal to 2 pi divided by omega, and that is equal to root over x1 square minus x2 square divided by v2 square minus v1 square. And this is the answer which is asking, and that's matching with the option number. Here it's given as minus this plus and minus this plus, so that is exactly same thing, but is matching with option number 1. Next, question number 4. String is stretched between fixed points separated by 75 centimeter. It is observed to have resonant frequencies of 315 Hz and 420 Hz. There are no other resonant frequency between them. The harmonic number of these frequencies, harmonic number is simply equal to f1 by f2, that is equal to 420, or you can write divided by 315, that's cancelling out, it's coming out to be 4 by 3. So f1, depending on which you are taking it actually, because f1 is given as 315, so it will be basically 3 and 4. So third and fourth harmonics will be the resonant. Third harmonic and fourth harmonic. This is third harmonic, this is fourth harmonic. Question number 5. This is matching with option number 1. Next, question number 5. Two vessels contain two different ideal gases A and B at same temperature. Okay, if ratio of molecular weights of A and B is given as 3:4, then the ratio of density of A and B, if pressure ratio is also given as 8:9. तो यहाँ पे पहली बात तो PV is equal to nRT, and rearranging it, P is equal to rho RT divided by M, and it's asking about the ratio. So rho is equal to P times M divided by R into T, and temperature of the both the gases is given as same. So this implies rho 1 by rho A by rho B is equal to PA MA divided by RT divided by PB MB divided by RT gets cancelled. This implies PA MA divided by PB MB, and this implies, so rho A divided by rho B is equal to PA by PB, it's given as 8 by 9, and MA by MB is given as 3 by 4, and this implies it's coming out to be 2 by 3. This is the answer, matching with option number 2:3, that's matching with option number 2. Next, question number 6. Two wave represented by y equal to a sine omega t minus kx and y equal to a cos omega t minus kx are superimposed, then the amplitude of the resultant wave, so amplitude of resultant wave is given by a sine of omega t, it's kx omega t minus kx, plus this is y1 plus y2 is equal to a cos of omega t minus kx. इसको अपन रीअरेंज करके लिख सकते हैं a root 2 into sine of omega t minus kx plus some phi, and that phi will be actually 45 degree. So we got, this is the resultant wave. Now amplitude of this wave is given by a root 2, and that's what exactly it's asking, matching with the option number 2. Next, question number 7. In a cylindrical rod of mass capital M, length L, in area of cross section A, hangs from the support, the extension produced due to its own weight is given by. तो यहाँ पे एक है अपने पास है rod, cylindrical rods, this. So here total mass M, total length L, and area of cross section A, so lambda is M by L. Now what will happen actually at this distance from here, let's say distance x from the lower end, length of this element is dx. The extension produced will be because of weight of this part. So weight is equal to, I can write lambda into x into g will be weight divided by area of cross section, stress, and we know actually stress upon strain is equal to y, and this can be written as basically, this implies strain means d delta divided by dx is equal to how much, this is stress, that is equal to lambda x g divided by a multiplied by y. Now multiplying it dx here, so this is the extension in this, and then integrating it here over d to complete delta. So delta is the total extension, and this is lambda. I can write it directly simply m by l multiplied by g divided by a multiplied by y, and x square integration 0 to l, so that's coming out to be l square by 2. 1 l gets cancelled, and this is the total extension, that is equal to mg capital L divided by 2ay, and that's matching with option number 4. So this is the answer to question number 7. Next, question number 8. Let me raise the board. Okay, so next, question number 8. If rho is the density of water and B is the bulk modulus, then the energy density of the water in the lake at h meter depth. So this is also a good question. So first thing is at h meter depth, this is delta P is equal to rho g h, and this is your pressure stress. We know bulk modulus is equal to what? Delta P divided by epsilon. This implies epsilon is equal to rho g h divided by B. And we know the energy density U is equal to half times sigma times epsilon, and that's equal to 1 by 2. Sigma is equal to rho g h multiplied by this is rho g h divided by B. This implies rho g h whole square divided by 2B. This is the energy density U, and that's matching with option number 4. Question number 9. Pick out the right choice. S square equal to a t power 4, where S is measured in meter, t is in second, then the unit of. So this is S square is equal to a t power 4 S L square a. This is t power 4. This implies a is equal to L square t minus 4, and that's matching with option number 4. Question number 10. In CJ system, the magnitude of force is 100 dynes. In another system where the fundamental physical quantities are 1 kilogram, meter, and minute, magnitude of the force. So here we know actually this is let's say x into in unit 1, and I'm like system. X is the quantity, magnitude, unit u1 equal to x2 into u2 units, and these conversions. So here 100 dynes, so gram, meter, gram, centimeter, and second square. This is, let's say here the unit magnitude is x, it's kg, so it's equal to 1000 gram, and meter, that means 100 centimeter, and second, that means 60, I'm like, because it's minute, so 60 second whole square, second into 60 second. Now we need to get the value of x, so this multiplying it cancelled out, 0 cancelled out, 36 divided by 10, so x is equal to 36 divided by 10, that's coming out to be 3.6, and that's the answer matching with option number 3. Next, question number 11. To estimate g from the relation g equal to 4 pi square L by t square, error in measured value of L is plus minus 2%, and error in measurement of t is plus minus 3%, that error in estimated g will be equal to. तो यहाँ पे ये अपने पास g दे रखा है 4 pi square into L by t square, taking log and differentiating and all that, we get delta g by g is equal to delta L by L plus 2 times delta t by t, multiplying by 100 by 100 by 100. It's in percentage. This is what required. This is given as 2%, and this is given as 3. 2 multiplied by 3, that's equal to 8 plus minus percent. This is the answer matching with option number 1 for question number 11. Question number 12. The pressure at the bottom of the tank containing a liquid does not depends on, so pressure depends on rho g h plus p naught at the bottom of the liquid, and it depends on area, acceleration due to gravity, it depends actually, height of the liquid column, yes, area of the bottom surface, it's not depending, and nature of the liquid means density, it also depends. So right answer is 3, does not depends. Next, question number 13. Two different liquids have density d1 d2 respectively. If same volume of both the liquids is mixed together, then the density of the mixture, density of mixture, total mass divided by total volume. So volume is same, density d1 d2, so mass I can write d mixture, that's equal to total mass, that is equal to d1 into v plus d2 into v divided by total volume. This cancelled out, this implies d1 plus d2 divided by 2 is the density of the mixture, which is matching with option number 4. Next, question number 14. Mercury in a barometer stand at 75 centimeters by the side of the lake of freshwater lake. An air bubble at the bottom of the lake, when rises to the surface, its volume becomes 3 times its volume at the bottom. If specific gravity of the mercury is 40 by 3, then the depth of the lake is. तो यहाँ पे ये मान लेते हैं surface है, this is the depth of the lake, let's say h, Then here volume is V, here volume is becoming 3V. Pressure, let's say P, that will be P naught plus rho G H, and this will be equal to P naught. So by considering isothermal expansion from here to there for the bubble, so we can write it actually P naught, I'm like P here. Okay, so P naught plus rho G H multiplied by volume, this is equal to P naught multiplied by 3 times of volume. V gets cancelled out. This implies rho G H is equal to how much? 2 P naught. And P naught is equal to what? 75 centimeter of mercury. So that means this is equal to 2 into rho mercury into G into 75. I'm taking that height in centimeter, so this will be also in centimeter correspondingly. Now this is G gets cancelled out. This implies H is equal to how much? This is 2 multiplied by 40. This divided by this is the specific gravity, that is 40 by 3 multiplied by 75, and this is 25. So this is 25 into 4, that's 100, and 2, this is 2000 centimeter, and that's equal to H is equal to 20 meter. This is the answer matching with option number 4. Next question number 15. 150 gram ice at 0 degree Celsius is mixed with 10 gram steam at 100 degree Celsius. Then final temperature of the composition under the ideal condition is. So यहाँ पे है ice, steam. तो अभी क्या होगा? Steam पहले cool down होगा. I mean like it will convert into first steam will be like condensing to water at 100 degree Celsius. Then it will cool down further. So let's consider this is how much? 150 gram ice to melt. Just to become water at 0 degree Celsius, heat required is multiplied by 80, and that's coming out to be how much? This is 12,000 calorie. Okay, so this will be ice to water at 0 degree Celsius. Next, steam. So 10 gram steam at 100 degrees Celsius, it will be like converting into 540, and this is giving you 5400 calorie energy. If it is so, means to melt the ice still we need more energy. Now if this 10 gram of steam is getting cooled down up to 0 degree Celsius, then how much heat further it can release? That will be equal to 10 into 1 into 100. So means that's equal to how much? 1 more thousand. So it's 6400 calorie. Now just see it. आइस को यहाँ से जस्ट मेल्ट करने के लिए इतनी एनर्जी चाहिए, और ये स्टीम से 0 डिग्री सेल्सियस तक आने में इसको इतनी एनर्जी रिलीज कर सकता है. दिस इज मच लेस देन दिस मच. तो मतलब क्या होगा? ये पूरा आइस तक मतलब लाइक 0 डिग्री तक आ जाएगा, तब भी ये पूरा आइस मेल्ट नहीं हो पाएगा. सो व्हाट विल बी द पॉसिबल टेम्परेचर ऑफ द मिक्सचर? दैट विल बी सिंपली डेफिनेटली, बिकॉज इवन complete ice will not be able to melt by this much amount of energy which is released by steam from 100 degrees Celsius to 0 degree at water. So means the final temperature of the mixture will be simply equal to 0 degrees Celsius. That's matching with option number 4 for question number 15. Next question number 16. So here it's saying the source and sink temperature of Carnot engine are 327 degree means 600 Kelvin and 27 degrees Celsius respectively means 300 Kelvin. Efficiency of the Carnot engine. So efficiency is given by 1 minus T2 by T1. This is 300, this is 600. So this is equal to 1 minus 300 divided by 600. That's equal to 0.5. That's equal to 50%. And that's matching with option number 2. Question number 17. A meter stick is balanced on a knife as at its center. When two coins each of mass 5 gram are put on one on top of the other at the 12 centimeter mark, stick is found to be balanced at 45 centimeter mass of the meter stick. तो देखो अभी क्या हो रहा है, ये मीटर स्टिक है और ये 45 पे बैलेंस हो रही है. दिस इज 45 मीटर सेंटीमीटर एंड 12 सेंटीमीटर पे 2 स्टोन. दिस इज 10 ग्राम. Let's say that linear mass density is lambda. तो इसका मास कितना हो जाएगा? 45 into lambda 45 into lambda, which will be center of mass will be at 45 by 2. So total torque on both sides must be balanced. So this you can write 12 and 45. So this will be like 33. So this you can 10 into g multiplied by 33 plus 45 into lambda divided by 2 multiplied by g multiplied by 45 must be balanced by, this is 55 multiplied by lambda multiplied by 55 by 2. So balancing these two multiplied by g gets cancelled, and 2 then it's 20, and taking it so this implies 20 multiplied by 33, taking that side and taking 5 common, so it's basically 25 multiplied by lambda multiplied by 121 minus 9 into 9 like 81, so that means 25 multiplied by 40 multiplied by lambda, and this implies 0 gets cancelled. This is 2 500, and lambda is equal to 33 divided by 50. This is gram per centimeter. So total mass m is equal to 33 divided by 50 multiplied by 100. That's coming out to be 66 gram. So the mass of the meter stick is 66 gram. That's matching with option number 2. This is question number 17. Next, question number 18. Okay, so next question number 18. The angular position of the particle revolving about an axis is given by theta is equal to t square minus 3t plus 4 radian. Find the acceleration of the point at the time t equal to 2 seconds given the radius of the path is 1 meter. So question number 18, theta is equal to t square minus 3t plus 4. यहाँ से अल्फा आ जाता है अपने पास 2, and tangential acceleration is given by r alpha, that is equal to radius is given as 1. So this is 2 meter per second square, and centripetal acceleration will be like velocity, so omega will be equal to 2t minus 3, and omega at t equal to 2 second will be equal to 1 radian per second, and then v is equal to, or a centripetal is equal to r omega square, that is equal to 1. So total acceleration is equal to root over ac square plus at square, that is equal to root over 1 square plus this is equal to 2. Tangential acceleration, that is equal to 4, that is equal to root over 5 meter per second square will be the total acceleration. That's matching with option number 4. Next, question number 19. Large number of particles are distributed on xy plane and their center of mass is at origin of the coordinate. Then sum of moment of all the, only one option is correct, sum of moment of all the particle with respect to origin is 0. Sum of moment of all the particle with respect to origin is 0. No, it will, okay. Sum of moment of all the particle, okay. Sum of moment of all the particle about the x-axis is 0 also. Sum of moment of all the particles about y-axis is, तो यहाँ पे देखो ये इस तरह से distributed है. This is the origin. So particles are distributed in a manner such that center of mass is lying at origin. तो उस टाइम पे अब आप इसका center of mass, so you can write moment of is m center of mass into position square, so that will be like simply center of mass. So even about x-axis it will be yes 0, about y-axis because it's exactly at origin so it will be 0, and sum of moment of all the particle about y-axis also 0, sum of moment of all the particle with respect to origin, that is also 0. So means all three all will be like correct option, so right answer will be matching with option number 4. Next, question number 20. Body of mass 2 kg is acted upon by two forces 2 Newton and 5 Newton in the direction this respectively. If the body is displaced from position this, then work done. Okay, so let me first write. So what is the total force? F is equal to 2 in the direction of I cap plus j cap divided by root 2 plus 5. This is j cap, wait a second, minus k cap divided by root 2, and this is coming out to be 2i cap plus 7j cap minus 5k cap divided by root 2. This is the force. Displacement, final position minus initial position, so s bar is equal to how much? This is like minus 4i cap, and it's 2 minus 2, so plus 4j cap, and this is 3 minus 1, so basically plus 2 k cap. Then W is equal to F bar dot S bar because it's constant. So multiplying and getting it, this is coming out to be minus 8 plus 28 and minus 10 divided by root 2, and this is coming out to be 10 by root 2, that is 5 root 2 joule is the work done. That's matching with option number 2. Here answer given is 1. That's not right, actually answer will be correct, answer will be 2. So work done will be 5 root 2, not 10 joule. So the answer will be 2. Next question number 21. Engine of car supplies constant power to the car with the acceleration which accelerate from rest. Car move along straight road if velocity and displacement of the car at any time are given by S and V respectively. Then so power, constant power is supplied, we can rewrite as M into V into dV by dt. This is constant, power is constant, so this implies integrating it, mv dv is equal to p dt. Integrating it, this implies mv square by 2 is equal to pt, and v is equal to 2p by m root over into t power half. Integrating it, ds by dt, so means v is directly proportional to root t. Is there any option? No, it's only about s. Let's check for that too. So this is some alpha into t power half. This implies again into dt. So s integrating again, s is equal to alpha t power 3 by 2 divided by 3 by 2. So this implies s is directly proportional to t power 3 by 2, which is matching with option number 3. So that is the answer to the question number 21. Next question number 22. Pump is required to lift 1000 kg of water per minute from a well 20 meter deep and eject at the speed of 20 meters. So power आपको पूछा गया, power of the engine. So power means how much work is done on total 1000 kg of water divided by 60 means total time, that will be the power. So to lift it from 20 meter depth, that means mgh plus kinetic energy half mv square. So 1 by 2 into 1000 into 20 into 20. So 1 2 gone. So this is how much? This is a overall total work done divided by 60. So this is coming out to be basically let me write it kilo. Then we are left with 200, and this is 200, so it's 400 divided by 60 kilowatt, and this is 40 by 60, that is 6.6 kilowatt is the answer, matching with option number 1. Next question number 23. Particle of mass 0.1 kg is subjected to a force F which varies with distance as shown in figure. If it starts its journey from rest means initial velocity 0, then its speed at 12 meter. तो speed के लिए अपन पहले work done निकालते हैं. Work done will be area under this graph. Area is given by 1 by 2 into height, that is given as 10 multiplied by sum of the parallel side, that is 12 plus it's 4 16, so it's coming out to be 80 joule, and this is equal to half m into v square. Mass is given as how much? 0.1 into v square, and this is implies v square is equal to 1600 and v is equal to 40 meter per second. 2 into 8 160 and 0.1, so that's all. So the speed is 40 meter per second, that is matching with option number 3. Next question number 24. Okay, so a point mass 1 kg collide elastically with a stationary point mass 5 kg. After their collision, 1 kg mass reverses its direction and move with a speed of 2 meter per second. For the system of these two masses, kinetic energy of the system, center of mass of this. Okay, so like we know actually after collision v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2 m2 divided by m1 plus m2 into u2. So 5 kg u2, I'm like that is at rest. Initial velocity, let's say u, and this is given as minus 2. This is 1 minus 5 divided by, this is 6 multiplied by u, and this is equal to 0. So this implies 2 minus gets cancelled, and that will be 4, and so we are getting left u is equal to how much? It's 3 meter per second. So then velocity of center of mass vcm is equal to 3 into 1 plus 5 into 0 divided by 6, that is 1 by 2 meter per second. Then kinetic energy of center of mass is 1 by 2 into mass total 6 multiplied by vcm 1 by 2 into 1 by 2, and that's coming out to be 3. So it's 3 by 4, that is 0.75 joule. That's the answer, matching with option number 1. Next question number 25. A ball of mass m is thrown upward with the velocity v. If air exit and average resistance force r, the velocity with which the ball returns to the thrower is. तो यहाँ पे देखो initial kinetic energy क्या है, half mv square, and that will be like converted into potential energy plus work done by resistance force. So I can write half mv square means mv square by 2 is equal to mg plus r multiplied by, let's say, height h. Okay, and when it's falling back down, then these mg will be doing positive work and r will be doing negative work. So work done is equal to mg minus r multiplied by displacement is still h, and this will be equal to final kinetic energy half mv prime square. Is it? So now what it's asking, v2 it's asking basically. So just dividing, let's say this is equation number 1, this is equation number 2, so dividing equation 2 by 1, so mv square, so it's v1 square divided by v square, and initial speed is given as v. This is equal to mg minus r divided by mg plus r whole, and this root over that multiplied by v. So this is the answer matching with option number 3. Next question number 26. So here it's saying, in the arrangement shown in figure, pulley A and B are massless. If frictional massless frictional and threads are ideal, block of mass m1 will remain at rest if. तो यहाँ पे देखो आपके लिए सिस्टम क्या दे रखा है, this is the system pulley, this is m1 which is supposed to be remain at rest, this is m2 and m3. तो यहाँ पे जो होगी tension T, here tension 2T. If 2T is balancing exactly this m1 into g, so 2T is equal to m1 into g, this block will be at rest. So let's calculate first T. So T is equal to how much? 2 m2 m3 into g divided by m1 plus m2, and multiplied by 2, this should be equal to m1 into g, and now simplifying it, g gets cancelled out, and dividing it, so 4 by m1 will be equal to 1 by m2 plus 1 by m3, and that's the right answer matching with option number 3. Next question number 27. Let me first erase the board. Okay, so next question number 27. A particle is projected from the ground with velocity v at an angle theta to the horizontal, and so that horizontal range is twice the maximum height attained. Neglect air resistance and symbol have their usual meaning. The maximum height attained by the particle. तो यहाँ पे range क्या है? U square sine 2 theta divided by g, and maximum height is u square sine square theta divided by 2g, and it's given as velocity is given as v naught square v naught, and theta is angle of projection. So that horizontal range is twice that of maximum height. Range is twice that of maximum height. Simplifying it, this cancelled out, v naught square sine 2 theta, this is 2 sine theta cos theta, and this is sine square theta. So 1 gets cancelled. This implies tan theta is equal to 2, and this implies sine theta is equal to how much? This is 2 by root 5. Then maximum height h max it's asking, that is u square or v naught square into sine square theta divided by 2g. Substituting everything, this is v naught square into 4 divided by 5 into 2 into g, and this implies 2, and this is equal to 2 v naught square divided by 5g. This is h max. That's matching with option number 1. Next question number 28. So a particle of mass m is connected with an ideal string of length l. Other end of the string is fixed and the particle is given root 5 gl velocity at bottom. It revolves in vertical circle, then the speed of the particle when string make an angle 60 degree with the horizontal. तो यहाँ पे vertical circular वाला motion है, and we need to apply here velocity is given a root 5 gl. So at some angle here, speed is let's say v. Then by conservation of energy, we can write 5 gl half mv square is equal to mv square, that is final velocity v square plus 2 gl 1 minus cos theta. Simplifying, theta is equal to 60 degrees, so this is cancelled out, so v is equal to root 4 gl, v square is equal to this, and v is equal to this, that is matching with basically 2 root gl, matching with option number 2. Next question number 29. two masses m1 m2 are suspended together by a massless spring or spring constant k. When the masses are in equilibrium, m1 is removed without disturbing the system, the amplitude of the vibration. तो इस केस में देखो क्या हो रहा है basically. Let's say two masses m1 m2, or let me write this is m2 m1. तो अभी क्या हो रहा होगा, लेट्स से दिस इज द इक्विलिब्रियम पोजीशन, तो ये यहाँ से यहाँ तक एक्सपेंशन हो रहा होगा x इज इक्वल टू व्हाट m1 प्लस m2 इंटू g डिवाइड बाई k. दिस इज द टोटल एक्सपेंशन. जब इसमें से एक को इसको हटा दिया जाएगा देन इट विल बी लाइक दिस विल बी इट्स नेचुरल लेंथ. तो नेचुरल k, अगर ये नेचुरल लेंथ है बेसिकली दिस इज द टोटल एक्सपेंशन दैट इज गिवन बाई दिस. अब बाद में क्या हो जाएगा, नेचुरल लेंथ ये है और बेसिकली इक्विलिब्रियम पोजीशन ये हो जाएगी, ठीक है ना. और यू कैन राइट दिस इज द इनिशियल इक्विलिब्रियम पोजीशन दैट इज दिस मच एक्सपेंशन. Later on equilibrium position is this, but it will be here. So how much will be this? That is equal to m1 into g divided by k, and this will be let's say x1. अब बाद में क्या हो रहा है, जब इसको हटा देंगे, ये हटा देंगे, तो मतलब क्या हो गया, पार्टिकल ऐसे समझो यहाँ से रिलीज किया जा रहा है और इसका इक्विलिब्रियम पोजीशन ये है, राइट. नेचुरल लेंथ ये है, तो इक्विलिब्रियम पोजीशन से जो डिस्प्लेसमेंट है, राइट, बेसिकली. एंड तो ये डिस्प्लेसमेंट में कितनी कमी आएगी, ये टोटल था और कमी कितनी आई, दिस मच, एंड दैट इज इक्वल टू दिस. दिस इज द एम्पलीट्यूड एंड दैट्स so amplitude is given by m1g divided by k, and that's matching with option number 1. Next question number 30 here. So we have two sphere, one of which is hollow and other is solid. They have identical masses and moment of inertia about their respectively diameter. Ratio of their radius is, so two sphere, one of which is hollow and other is solid, okay, have identical masses and moment of inertia. Masses भी equal है और moment of inertia, but radiuses are different. Ratio of their radius. So for solid sphere it's given by basically we have two sphere, one is hollow. For hollow it's given by 2 by 5 m into r 1 square, and moment of inertia, and this is hollow, it's 2 by 3. Another is 2 by 5 solid, m into r 2 square, m gets cancelled, this gets cancelled, this implies r1 by r2 is equal to how much, root 3 by 5. This is the ratio of their radius, that is matching with option number 3. Question number 31. Hollow sphere of volume V is floating on the water surface with 1/4 immersed in it. The minimum volume of the water that should be poured in the sphere so that it completely sink. तो अभी क्या हो गया, इसका जो मास है ना mg, that is given by v into rho water into g divided by 4. तो इतने से बैलेंस हो जा रहा है. अभी जो वॉल्यूम लेफ्ट कितना है, वो कितना है 3v/4. तो आप इसमें जब वाटर फिल करेंगे तो एक्जैक्टली उतना ही अमाउंट ऑफ वाटर फिल कर देंगे तो पूरा का पूरा सिंक हो जाएगा. सो द वाटर एडेड नीड टू बी एडेड इज 3v/4, बिकॉज इतना वॉल्यूम ऑलरेडी अंदर है जो कि इसके वेट को बैलेंस करने के लिए. अब खाली कितना है 3v/4. अब इतने में वाटर का ही जब लिक्विड भरेंगे तो कोई एडिशनल फोर्स, बायंसी फोर्स कुछ नहीं आएगा. इट विल सिंपली सबमर्ज दैट कंप्लीटली. सो द एडिशनल वाटर रिक्वायर्ड टू submerge it completely, is it sink it in completely, that will be equal to 3v/4. Next question number 32. So here select the correct PV cyclic curve for the ideal gas of constant mass whose VT graph is given in. So यहाँ पे आपको VT graph दे रखा है. This is given as this. This is V and versus T, and it's starting from here A, B, C like this. Okay, तो अभी देखो इसके लिए क्या करना होगा. बेसिकली दिस इज वी नीड टू कन्वर्ट इट इनटू P into V. तो यहाँ पे पहली बात तो A से B क्या हो रहा है VT, and that's a straight line passing through origin, means it's a constant pressure process. तो यहाँ पे प्रेशर कांस्टेंट होगा तो either it will be here or either it will be here. ठीक है ना. अब उसके बाद तो ये A से B चला जाएगा. It can be here also, we need to check that. Then B to C, it's a constant volume process. Constant volume pressure. So now you can see temperature is decreasing, means pressure must be decreasing because volume is constant. So that means it must be downward. It cannot go further down. That's why it will be this process AB, BC. Now next is C to A, it's a constant temperature, means isothermal process, and C to A it will be like constant. So this is your process, and that's matching with option number which 4. This is the answer to question number 32. Next question number 33. Particle performing simple harmonic motion is shown in the figure. द करेक्ट इक्वेशन ऑफ SHM फॉर दिस सेम SHM सिंपल हैव देयर यूजुअल मीनिंग। तो यहाँ पे देखो पार्टिकल t इक्वल टू 0 से कहाँ से स्टार्ट हो रहा है, a/2 से। तो a/2 पे मतलब लाइक दिस इज इक्विलिब्रियम एंड दिस इज a/2। तो यहाँ पे जो अगर पार्टिकल की वेलोसिटी इधर होती देन फेज इज इक्वल टू हाउ मच, फाई इज इक्वल टू π/1/2 साइन 1/2 दैट मीन्स π/6। लेकिन जब ये इधर हो रहा है तो मीन्स हाउ मच इज लेफ्ट, pi minus π/6। that means like here if velocity is this side v, then phase will be equal to how much, pi minus π/6, that means 5π/6, and remaining it will be starting from origin. Phase is this, so the equation will be equal to x is equal to a sine of omega t plus 5π/6, 5π/6. This will be, an amplitude is given as how much, it's given as a, so the equation will be matching with option number 1. That is the answer to question number 33. Next, question number 34 here. So a motorcycle start from rest and accelerate along a straight line path at 2 meters per second square. At the starting point of the motorcycle there is a stationary electric siren. How far has the motorcycle gone when the driver heard the frequency of the siren at 94% of its value when the motorcycle was at rest? तो इनिशियली जब रेस्ट में था तो सायरन की जो फ्रीक्वेंसी ओरिजिनल थी वही मोटरसाइकिलिस्ट को फ्रीक्वेंसी सुनाई देगी, बाद में फ्रीक्वेंसी कम हो जाती है बिकॉज मोटरसाइकिलिस्ट इज मूविंग अवे. सो लेट्स से द स्पीड इज v and that will be equal to what, 80, because it's changing with time. So we can write 94%, so means 0.94 f naught is equal to f naught into v minus v driver divided by v. f naught gets cancelled out, and here what is given as speed of sound is given as, so it's 0.94 is equal to 330 minus v divided by 330. Simplifying it, यहाँ से अपने पास v आ जाता है, v is coming out. Okay, this is, so solving it basically we are okay. यहाँ पे आपको पूछा गया है how far, तो पहली बात तो अपन इसको सॉल्व करके, all right, just wait a second. So let me first, this implies, यहाँ से अपन this is 0.94 multiplied by 330 is equal to 330 minus v, and this implies v is equal to 0.06 into 330. This is the final velocity, and we can write v square minus u square is equal to 2a into s. So we are actually asked to find s, that is equal to 0.06 multiplied by 330 whole square, because initial velocity is 0, divided by 2, acceleration is also 2, and solving this we are getting s, and that's coming out to be basically 98 meter after simplifying it. So the answer matching with option number is 4. Next, question number 35. So here a car is moving away from a stationary observer such that the frequency observed is 6/7 of the original frequency. Given the speed of this, then the speed of the car. तो यहाँ पे अपने पास simple Doppler effect. So observed frequency is 6/7 f naught, original frequency, car moving, so its speed is given as 330 minus v car divided by 330. Again this simplifying it, 330 multiplied by 6 is equal to 330 multiplied by 7 minus 7 multiplied by velocity of car. 7 times velocity of car is equal to 330 into 7 minus 6, that is equal to 330 divided by 7. So velocity of car is coming out to be such, it's like I think okay, here one second, car is moving away from the stationary, okay, observer, I did mistake, actually car itself is the source and which is moving away. So here we need to source, then it's like moving away, velocity of car, so it will be like equal to, just a small correction, so 6 times 330 plus 6 v car is equal to 7, 330 multiplied by 7, so 6 v car is equal to 330 multiplied by 1, and velocity of car is 330 divided by 6, that is equal to 55 meter per second. That is the speed of the car, matching with option number 4. Next, question number 36. All right, so let me first erase this part. Okay, so next, question number 36. A particle is projected from the ground and with the initial velocity v at an angle theta with the horizontal, then the average velocity of the particle between its point of projection and highest point of trajectory. So question number 36. तो यहाँ पे पार्टिकल को प्रोजेक्ट किया जा रहा है like this, and ये पॉइंट्स के बीच में नेट एवरेज वेलोसिटी पूछी गई है. सो एवरेज वेलोसिटी along this displacement divided by time taken, it's simply u cos theta. Along this displacement is h max and time is t by 2. So v y average, that is equal to u square sine square theta divided by 2g divided by time of flight is u sine theta multiplied by g, and this implies this is coming out to be u sine theta divided by 2. Then average velocity, or it's asking about speed of the car. No. Alright, so average velocity of the particle. So this is average velocity along y direction, along x direction. Then mod of this is equal to, magnitude v is equal to root over this square u square cos square theta plus u sine theta by 2 whole square, that is coming out to be basically u square by 2 u by 2 root over 1 plus 3 into cos square theta. This will be the average speed, or that's matching with option number 3. Next question number 37. Speed of the light is c, acceleration due to gravity is g, and pressure p are taken as fundamental quantities. Then dimension of the gravitational constant. So पहले तो gravitational constant क्या हो जाएगा, f, that is m l t minus 2 multiplied by m minus 2 multiplied by l square, that is equal to m minus 1 l cube t minus 2, and this is equal to what? Let's say c power x and g power y and p power z, that is a l t minus 1 x, and this is l t minus 2 y, and pressure m l inverse t minus 2 power z. Now taking here l coefficient x plus y minus z, t coefficient minus x minus 2y minus 2z, and m coefficient, this will be equal to z. Comparing these coefficient with these coefficient, we are getting z equal to 1 minus 1, and similarly simplifying for others, we are getting y is equal to 2 and x equal to 0, and this implies we are getting the dimensional formula for g in terms of these fundamental quantity will be equal to, so x is equal to 0, so c power 0, y equal to 2, g 2, and z, that means like p power minus 1, and that's matching with option number 2. This is the answer to question number 37. Next question number 38. So here a wave traveling along positive x-axis is given by this. It is reflected from rigid boundary such that 80% of the amplitude is reflected than the equation of the reflected wave. So equation of reflected 80% amplitude 0.8a into sine of omega t minus kx, and it's reflected from rigid boundary, so means phase plus pi, and this pi can be eliminated by taking here minus, and that's the answer which is matching with option number 2. Next question number 39. So a block A of mass m is placed over a plank B of mass 2m. Plank B is placed over a smooth horizontal surface. The friction coefficient between the A and B is 1/2. Block A is given a velocity v0 toward the right. Acceleration of B relative to A is. तो यहाँ पर है अपने पास, this is B mass 2m, this is A mass m, block given velocity v0. So इस पे क्या होगा, फ्रिक्शन इधर लगेगा, इस पे फ्रिक्शन इधर लगेगा. So acceleration of A is given by mu g, that is equal to backward. So this is you can write minus g by 2, and acceleration of A is equal to what? This is mu g divided by 2m. So mu g, that is 1 by g by 2 divided by mass 2m, and into m, this implies it's g by 4. So acceleration of this is b with respect to A, that is equal to g by 4 minus g by 2, that is equal to 3g by 4. This is the answer for question number 39, and here unfortunately no option is matching, so there is a mistake actually in this question also. The correct answer will be like 3g by 4. So you can write either there is printing mistake, so the third option should be 3g by 4. So the answer given here is 3, but that will be 3g by 4 will be the right answer, not g by 4. Next question number 40. Here let's T1 and T2 with the time period of the two springs A and B when mass m is suspended from them separately. Now both the springs are connected in parallel and the same mass is suspended from it. Then let T be the time period of this. Then what? So we can write 1 by T1 is equal to 1 by 2 pi root over K1 by M1. 1 by T2 is equal to 1 by 2 pi root over k2 by m. Then next time period t, 1 by 2 pi root over, isn't spring connected in parallel, it will be this. Squaring and rearranging, substituting the values, we are getting actually 1 by t square is equal to 1 by t1 square plus 1 by t2 square, and this is the answer which is matching with option number 4. यहाँ पे क्या करने का, देखो इसको स्क्वायर करो 1 बाई 2 पाई, और ये k1 बाई m वैल्यू यहाँ से रख दो, k2 बाई m यहाँ से रख दो, सिंप्लीफाइंग इट वी आर गेटिंग दिस. नेक्स्ट क्वेश्चन नंबर 41. For a cubical block, error in measurement of side is plus minus 1% and error in measurement of mass is this, then the maximum possible error in density. तो density क्या होता है, mass upon volume. Volume को अपन लिख सकते हैं L cube. This implies delta rho by rho is equal to delta m by m plus 3 times delta L by L multiplied by 100. We will get everything in percentage, 100. And this is also 100, so this implies this is the percentage error in density. That's equal to how much? This is mass 1 and length, let me just check it, mass 2%, so it's 2 and 3 times of L, that is 3 times of 1, that is equal to 5% plus minus. This will be the answer which is matching with option number 2. Next question number 42. So that's a small quantity of mass m of water at temperature theta is poured in a large mass capital M of ice which is at its melting point. If C is the specific heat capacity of water and L is the latent heat of fusion, then the mass of the ice melted is given by. तो यहाँ पे ice कहाँ से मेल्ट होगा, जो थीटा टेम्परेचर पे वाटर है वो कूल डाउन होगा, हीट रिलीज करेगा, दैट विल बी लाइक, सो हीट रिलीज्ड बाय m mass mc into temperature delta theta. This is, let's say, m prime mass of the ice has melted multiplied by length, latent heat of fusion. This implies m prime is equal to mc theta divided by capital L. This is matching with option number 4. Question number 43. The object hang from a spring balance. The balance register 30 Newton in air, 20 Newton when object is immersed in water, and 24 Newton when object is immersed in another liquid of unknown density. What is the density of other liquid? तो इसका मतलब air में, so V into sigma, let's say density of liquid, this is equal to how much? 30 Newton. When it's in water, so V into G into sigma minus 1, that is equal to 20 how much? Newton, and then V into G into sigma minus, let's say density of that water is rho, so it's 24 Newton. Okay, simplifying all this, यहाँ से basically simple कर सकते हैं. Rho is coming out to be 3 by 5 gram per cc, and that can be converted. Rho is equal to 600 kg per meter cube, and that's matching with option number 2. Next question number 44. So an object of radius r and capital M mass is rolling horizontally without slipping with the speed v. It then rolls up the hill to a maximum height h. Okay, h is given by 3v square by 4g. The moment of inertia of the object is, तो यहाँ पे देखो initially क्या हो रहा है, rolling without slipping, and finally it's with velocity कैपिटल M मास दे रखा है, रेडियस दे रखी है, विद स्पीड v. तो इसका मतलब टोटल इनिशियल काइनेटिक एनर्जी क्या हो जाएगी, हाफ mv स्क्वायर, ट्रांसलेशनल काइनेटिक एनर्जी rotational half I omega square, and omega square is v square by r square, and that will be equal to what? Finally rising, so it will be converted into potential energy mgh. So mg and h is given as how much? 3v square by 4, and simplifying it this v square, and that's all. तो यहाँ से अब अपन को पूछा गया है what it's asking. Okay, g is acceleration due to moment of inertia of the object divided by 4. So g gets cancelled, taking that side, this is I, v square also cancelled out. So this is basically I by 2 r square. This is equal to, I can cancel 2 also from here, and then this will be like 2, so this is also gone. Then m, okay, no, m will not be cancelling out, so m will be that side, so 3m by 2 minus m, that is equal to m by 2, and this implies I is equal to m r square by 2, and that's the moment of inertia. That's matching with option number 2. Next question number 45. So 45 में आपको दे रखा है friction coefficient between the two blocks as shown in the figure is mu, and horizontal plane is smooth. If blocks are slightly displaced by x from mean position, then the maximum friction force acting between them. तो maximum friction force basically act होता है जब ब्लॉक्स का क्या हो रहा है, एक्सेलरेशन मैक्सिमम हो, ठीक है ना। सो वो होगा जब एम्पलीट्यूड मैक्सिमम डिस्प्लेस्ड है। लेट्स से दिस इज द सिस्टम, क्वेश्चन नंबर 45। मान के चलते हैं यहाँ पे मैक्सिमम डिस्प्लेस्ड है, दिस इज m2, this is m1, this is the mean position, x maximum. So then acceleration is equal to how much? You can write k into x divided by m1 plus m2, and this will be actually provided by what? Friction force. So what it's asking basically, mean position, then the maximum possible friction force. So that will be actually equal to exactly acceleration on this. So friction force is equal to m into m1 into a, this is m1 into k into x divided by m1 plus m2. That will be the answer, which is matching with option number 1. And this is all about your paper DT13. That's all. I hope this video is helpful for you people in clearing your doubts, and that's all. Thank you so much.